We really appreciate your time. So I'm going to go ahead and start recording. So whoever will be coming in, if they don't get some part of it, we'll post it on YouTube. Okay. So today we are going to go ahead and get started on exceptional handling or exception handling. Okay. And exception handling, the way I would define it, it's just the way you design a program to handle errors. Okay. When a program, for example, is designed to say to handle, let's say, age of an individual, if the age is between this and this, then we accept, otherwise we reject. The way that's going to be handled, if for some reason we put, let's say we don't expect somebody to be more than 150 years old. If the person is more than 150 years old, the system should be able to gracefully handle that as an error. And that's what we call exception handling. So error handling increases the robustness of your code, okay, which guards against potential failures. Okay, that will cause your program to exit in an uncontrolled condition. If we allow the program to accept, let's say, uh, more than 150 years to the age of a person, and if that's not properly handled, then the program will eventually give you what we probably call some kind of an error, which might be either logical because it's not true. Okay. So if we can handle that, that means good. If you cannot handle that, that means it's a problem. And that problem is what we need to figure out to be able to avoid it from happening. Okay. Python has many built-in exceptions that are raised when your program encounters an error. Something in the program, if something in the program goes wrong, when these exceptions happen, the Python interpreter stops the current process, okay? And then it passes it over to the calling process until it is handled, okay? If not handled properly, the program will crash. Say you design a program which is supposed to be interacting with the operating system. Regardless of whatever operating system it is, you need it to be able to talk back to the operating system back and forth. And in our case, we have in Python, we can import the system, SYS, and we can also import the OS, which is operating system. And then you want your code to be able to clear the screen and to be able to tell you what directory or you're working on. Now, if for some reason your program cannot be able to do this and you try to go out of your comfort zone to say to find out, then that probably might be able to cause a program to crash. So we need processes in place to be able to gracefully handle those errors. So for example, let us consider a program where we have a function. Let's call the function A. That calls the function B, which in turn calls function C. Okay. If an exception occurs in function C, but is not handled in the function C itself, the exception passes to B and then to A. If never handled correctly, an error message is displayed and our program comes to a sudden, unexpected halt. If it was an e-commerce or it was a life-saving, let's say, equipment in a healthcare environment, that could be a problem. Imagine, let's say you are running some kind of heart machine to be able to help a patient breathe. okay? And suddenly, due to an error, the system crash and stop. That's gonna put somebody's life in jeopardy. Okay? Exception handling should be able to give us a screen, like a pop-up, and then give us information that, hey, you're running low on battery, or oh, there's a problem with the program which has just crashed. We need to be able to save your work. We are going to go ahead and exit in 10 minutes. That's a good way of doing exception handling. So when you're doing a programming like the one we did in scholarship, you say, you enter the name, enter first, last name, and then you enter all the particulars of an individual, okay? And then we enter, let's say, the Zoom, their Zoom points, their test score, we enter the quizzes. Now, if for some reason, let's say the quiz is supposed to be 0 to 9, and the score for the test supposed to be up to 10, but we give 1 point for each. If you don't specify that in the program, and your user for some reason, instead of putting like 0 to 9, but they put 18, you should be able to handle that as an error. That error, if it's handled properly, will not cause the program to crash. But if it's poorly designed, then your program will crash, and then it can crash the program and stop. Luckily enough, your program will not be running some critical system like, say, Nairobi Stock Exchange or New York Stock Exchange. So it's going to be all good. It's not going to cost you your job, but you need to know stuff like that need to be taken care of appropriately. Okay. So catching exceptions in Python. How do we catch the errors? In Python, exceptions can be handled using a try. We have a try as a keyword. So it's a try statement. The critical operation which can raise an exception is placed inside the try clause. Let me show you how that works here. If you look here, this is a try clause right there. Okay, so let's see here. Make sure I expand it for you. We put a try first, follow the column, and then we run the code in there. And then we put another exception, and then we put a column. So we say if they picked male, they need to put an M. Don't type the whole, let's say, don't type the whole word male. If they need to pick a female, just type F. Don't put the whole word female. If they don't do that, then give them this error. Otherwise, exit. That is a graceful way of handling an error. In a bad program, if you design the program, you just say, hey, go ahead and put the gender. Some people will put an M for male, some people will put an F for female, some people will type the female or the male, but your program does not tell them what they actually need to do. So I would say, for some people, this is probably already there, but as from today, you probably want to be able to put yourself in the shoes of the user of your program. How are they going to handle this input? What if this input is not put properly? How should I go ahead and let them know by giving them some kind of feedback? So it's always a very good thing. And this is the pattern it will always follow. So do the try, then run the code. Exception, execute this code when there's an exception. The exception is an error. Else, if there's no exception, then run this other code. Otherwise, finally, run the last code. Okay, so that's how we would pretty much handle errors in Python. So this I'll be able to send it to you so you can also have some of the code so you can actually try and look. So my example here is we import SYS, which is for system, and then we say we are going to go ahead and declare a loop. These are random numbers between, let's say, random number between 0 and 2. It's randomized, and then we print the entry, and then we are going to go ahead and say we declare the variable r, and then we say 1, we divide by the integer of the entry, which is going to be a number from there, and then we break, and then we put an exception, say oops, there's a system error, otherwise go to next and then print. This, you really need to start making sure that your program take into consideration the kind of errors which you might be having, and there are different types of errors out there. It could be a keyboard error, it could be the error on the system, it could be an operating system error, it could be a memory error. There's so many different types. So in this one, you'll be able to get this kind of error. Okay, so the entry is telling exactly what it is. Okay, now in the program which we just saw, we look through the values of the random list. As previously we mentioned, the portion that can cause an exception is placed inside the try. If you see here, whatever is going to be most likely causing problem, we have to put it inside the try. I'm sorry. Try will always work with exception. It's almost like you say if, else, or if, elif, they have to go together. Okay. So here we say if no exception occurs, the except block is skipped. If there's no problem, we skip it and normal flow continues to the last value. But if there's an exception, it is caught, we catch it. And then what do we do with it? Now that thing which we do with the exception is what we call error handling. Okay. Now we print the name of the exception using the ex underscore info. This is a function inside this. When you call the system, when you call this one right here, okay, you can use a function, this function here, to give you a specific type of an error if it's system related. Okay, so here, as you can see, we have a specific type of error. It tells you it's value error or 0. Like when you're running your Python code, you normally see different types of errors, and these are the errors. Could be you cannot divide by 0, so 0 division error, or it could be a value error, or it could be some kind of error, which in this case might be going beyond what we already have, right? Okay. So catching specific exceptions in Python, okay? We do that, of course, like in the above program, we do very specific using the except clause. This is not a good programming practice. Some cases whereby you really need to go an extra mile to make sure that everything is taken care of. Okay. So since I'll be sending these notes out, I will not dwell too much onto it. This is very straightforward. And if you have any question, you can always reach me. Okay. Okay. So I'm going to go ahead and pass it back over to, I believe that's going to be Lucy and Monica. And they'll take it from here on, and then we'll see what we can do. Okay. Thank you, guys. Go ahead, Lucy. Is that Monica or Lucy?
It's Lucy.
Okay, go ahead.
Okay, thank you so much. I'm going to share my screen. So today I have two topics to discuss with us, and I will start with the algorithm, and then after that I will proceed on control structures. So starting with algorithm, I want to start by saying that whenever we are writing a program, we are solving a problem. So basically, you have a problem and then you write a program to help you solve that problem. So every time you're coding, even if you're just writing a program that will help calculate the sum of some values, then you're solving that problem. The best thing to do before you start writing a program is to plan for it, is to design it. Just the same way, when somebody wants to build a house, you have to first of all start by drawing that house. You design it. You say that the bedroom will be here, the sitting room will be here, the kitchen will be here. You basically make a plan, and then now you start building the house. And that is how we have to write our programs. So an algorithm is a procedure for solving a problem in terms of the actions to be executed and the order in which those actions are to be executed. An algorithm is merely the sequence of steps taken to solve a problem. In other words, I would define an algorithm as a step-by-step procedure of solving a problem. The steps are normally sequence, selection, and iteration. And we have two types of algorithm that we write when solving a program problem. We have flowcharts and we have pseudocode. So the flowchart or pseudocode are types of algorithms that we can write when we are solving a problem or when we are designing a way to solve a code problem. So what is a flowchart? A flowchart is simply a graphical representation of steps. So when I talk of graphical representation, I'm saying that we are solving a problem, but we are designing the steps in a kind of shapes. We are using shapes to show how we are going to solve the problem. It shows steps in sequential order and is widely used in presenting the flow of algorithms, workflow, or processes. Typically, a flowchart shows the steps as boxes of various kinds, and they are ordered by connecting them with arrows. Most people like visualizing things. So the moment they see flowcharts or they see these boxes or these shapes, they want to learn more because it is easy, it presents it in a more visual manner. So these are the types of shapes that we use when we are designing our flowchart. It is standardized, it is worldwide. You cannot create your own shapes. So you pick these shapes and they are understood as such by all programmers. The oval is a terminator. It demarks the start and the end. So when you're writing your flowchart, you use the oval to show the start or the end of the process. You use the arrow to denote the direction. And whenever you're dealing with the arrow cannot go zigzag. The arrow cannot go diagonal. The arrows must go straight horizontally or straight vertically. So the direction can either be two-way round, but both have to be horizontal. Parallelogram is where you show where your inputs go and where your outputs go. It represents an input or output operation, and you have to put your inputs and your outputs in a parallelogram. The rectangle denotes a process to be carried out. So if like you want to do a calculation, you put it in a process. You want to assign some constant value, you put it in a rectangle, and you don't mix these shapes. A rhombus shows a decision. It shows the way the results will branch as you take maybe one direction and leave the other. So you realize that when you have a rhombus like this, you will put your condition inside here. The condition is most of the time also referred as the expression. So you put your condition inside there, and remember, the result of a condition is normally either true or false. So you can decide whether to put your true here and to put your false here, but it has to branch twice. So the statement that comes here will be performed if this is false. So you must show false, true, and whatever execution happening here will be performed if this condition is true. So that is how we use the rhombus. We have a terminator, we have a connector, same page connector. Most of the time when you are drawing these shapes, you realize that you may have started from this and you have drawn until you reach the end of that line. So on the same page, you want to come and maybe start on a different line. What you do, you show the connection. So whenever you're putting your connection, you must put some letter inside here. So maybe letter A, and as you come this other side, you start by putting your letter A, and then you continue with the process as you are doing it. This will help so that if there are several connections, then any other person working with your flowchart will know that this A was connected with this A. A C was connected with a C. Different page connector, this is the shape that you use. And of course, you must put some letter inside to indicate that this connector was the one connecting with the other one on a different page. The sub-programs, they are called differently in different programming languages. In some programming languages, they are called subroutines, others they are called procedures, others they are called functions. And so whenever you are indicating that this is a function, then you use this shape to put your sub-program or sub-procedure. So these shapes are worldwide. They are known, and these are the shapes that you go with. One very important thing to note is that when you're designing an algorithm, You do not follow the syntax of any language. You write your algorithm generally for any programmer to use. It is a design. You don't use the syntax of a language. So you make it global that any coder is able to pick your algorithm and write a program for it. So I had already said that as you're showing your algorithm, you can either go with a sequential program, a selection program, or an iteration program. A sequential program, of course, I'm going to show these when I'm going to touch on control structures more, but just to indicate or just to show us how we write algorithm or how we design our flowcharts in a sequential program. A sequential program is a program that the flow of execution begins from the begin to the end without branching or looping. So once you start, you do something, then you do something, then you do something, then you do something, then you end. Basically, what is important to note is that in your oval, which we said is the shape to show begin, you must write this word start. And on the last one, you also must indicate end. So you can either say begin, end, or you can say start, end, or you can say start, stop. But these two must always be there. An algorithm or a flowchart or a pseudocode must have a start and an end. The next thing you do is maybe you want to say input. So you say input X, input Y. The sum is X plus Y. Average is sum divided by 2, and then output the average. So if I pick this, I can go and write a code in C and I follow this. Another person can take it, use it on Java. Another person takes it, use it in Python. So it does not follow any syntax of any language. A flowchart to show decision would go like this: decision or selection. There has to be a start. So probably this program may not be starting from here. Maybe you have input some things up there, and then at some point you now join a condition. So we will have like, you put your condition, you indicate what to do when the condition is false, and you also indicate what to do when the condition is true, and then you continue, maybe end, or you continue with the other steps that you need to follow. But generally, the selection portion would look like this. So you indicate your rhombus, you go this direction, you go this direction. And I had shown that again earlier. For looping structure, this is how you would design your flowchart. So this is an example of a flowchart showing a procedure for making the tea. So I indicate start, fill kettle with water, heat water. And then you ask a question, or you put a condition. Has the water boiled? No. If the water has not boiled, then go back and continue heating. Come here, ask the same condition. Has the water boiled? No. Go back, heat water. Has the water boiled? No. Heat water. Has the water boiled? No. Heat water. Has the water boiled? Yes. Once the water is boiled, now make tea. Then after you have made the tea, stop. So this will show somebody that the looping takes place at this portion. Once the looping condition has expired or is no longer true, then you go to whatever you need to do next and you continue. The pseudocode, unlike flowchart, is a type of structured English that is used to specify an algorithm. Pseudocode cannot be compiled, not executed. Pseudocode is independent of any programming language, just like I had said earlier. So unlike flowcharts, pseudocode, we use English, and now it is very important that you note that it is independent of any language. You don't write a pseudocode following a particular language syntax. The tips or some rules for designing a pseudocode will include: number one, always capitalize the initial word. Like if you want to say start, stop, then make that in capital letter. Have only one statement per line. You cannot have two statements in the same line, maybe separating with commas or whatever. Have only one statement per line. Number three, indent to show hierarchy, to improve readability, and show nested constructs. Number four, always end multiple selections using any of the keywords and. So you would say end if, end while, etc. And we are going to see that in examples that I'm going to give. Keep your statements programming language independent, because if I am not a Python programmer and you put your pseudocode in Python syntax, then I will not be able to use your pseudocode. That's why we say keep it independent of any language. Use the naming domain of the problem, not that of the implementation. For example, you can say append the last name to the first name instead of saying name is equals to first plus last. Keep it simple, concise, and readable. So those are tips that you must always remember when you are designing your pseudocode. For a sequential program, an example of a pseudocode, I would say begin, input hours, input rate, pay equals hours times rate, print pay, end. So anybody I give this pseudocode will be able to write this program in whichever language that person prefers. I'm giving two examples for selection. So example one is helping to calculate interest rate based on amount. So in that portion where you're doing selection, you would say, if amount is less than 1,000, remember I am indenting. So these are the very, very important things that you need to know. If amount is less than 1,000, so this is capitalized, and then I have indent here. Interest rate is equals to 0.06. So that means this block of code or this statement will be done if this condition is true. Else, interest rate is equals to 0.10, and then end if. So these three that are written in capital letters are very, very important. They show you that I am beginning this, I am doing when it is true, I'm doing this when it is false, and this is the end if. So anything that is following is not part of this block of code. Example 2, input game number to decide which game to play. So the first thing I'm saying, read game number. If game number equals 1, do solitaire. Else, if game number equals 2, do Doom. Else, do Monopoly. And if. So you see exactly the way this follows here and this follows here. So the indent is very important so that any person working on this code will be able to just see your block, the way you have put it, the way you have arranged it, and that person is able to pick on it. To show looping, example, a pseudocode for making T procedure, just the T procedure that I have shown in the other example that I was doing. Number 1, I am saying start. So this I have started from the very beginning, start. Number 2, fill water in the kettle. Number 3, heat water. So remember, I am saying heat water, and then I start with my condition. While water has not boiled, heat water. So this is the statement that is going to be repeated a number of times. You will continue heating water until it is boiled, because the condition is you heat it as long as it is not boiled. Once it is boiled, now end while. Remember, end while goes there, and then make tea, and then stop. So once you stop, that will be all for algorithm. And the next I will start now is control structures. The control structures, I will define control structures again as I am beginning. Control structures are principles of every programming language that I've always come across. So control structures are basically principles that go with nearly all programming languages. They include selection, iteration, and sequential. So control structures shows the execution flow. The control flow of a Python program is regulated by conditional statements, loops, and function calls. So for tonight, I know Monica will be talking about function calls, and I will talk about sequential, the loops, and conditional statements. The sequential is the default mode. Selection is used for decisions and branching. So we call them selection, decision, or sometimes we just call them branching. And then we have repetition, which we refer as looping, or most of the time we just say iteration. A sequential program. A sequential statements are a set of statements whose execution process happens in a sequence. The problem with sequential statement is that if the logic has broken in any one of the lines, then the complete source code execution will break. So every time we are writing a program, basically it moves from the beginning to the end. So we say, for example, A equals 20, B equals 10, C equals A minus B, and then print subtraction is equals to C. So if I did not maybe say what A is, If I just come here and maybe I don't use this, so I say B equals 10, and then I say C equals A minus B, then this code will not run. Why? Because A is not known. So it has to go step by step from the beginning to the end. So that is basically just on sequential. Most of the programs we have written, we have catered for that. Selection or decision control statements. In Python, the selection statements are also known as decision control statements or branching statements. The selection statements allow a program to test several conditions and execute instructions based on which condition is true. We have 4 different types of decision structures: the simple if else, nested if, and if elif else. So when I'm dealing with control structures, I'm very, very particular on Python syntax. Simple if is a control flow statement that helps us to run a particular code, but only when a certain condition is met or satisfied. A simple if only has one condition to check. So the syntax will go like if condition, full colon, then you indent, and then you do something. So this is the place where now you will allow me to launch this. And for example, I just want to go by showing. So I would say X equals 5, and then I have Y equals 7. And then I put my if. So I say if X, so I just want to check if X is greater than Y. And then you put a full colon. Remember that it's very important. If X is greater than Y, full colon, you indent, and then you say print. And then I would say X is greater than Y. So I run this. It should be able to run. I don't know why I'm not getting my results.
You have the right indent, Lucy?
Hello?
Is the indent correct for? Looks like it's
Yeah.
short.
I'm sure. Just checking what it could be wrong with my. Let me launch a new one.
Launch a new one.
Yeah,
Close-
that's
close-
what.
Close that one.
X is capital again.
Let me close that and just launch a new one.
One
So
of your X is capital. One of your X is capital.
one of
Your X, the print X, X is capital.
No, that
Oh.
one is okay.
it's okay, it's fine.
It's within the quote.
Yeah, it's good, it's good. Let me just do it again. If sorry, I need to first of all have my X ready and also my Y ready. So Y I'm assigning to 7 and I'm saying if, and then now X is greater than Y. Full colon is very important. It is part of this syntax. Then now I have print X is greater than Y. I run this.
Close the Lucy, close the welcome to Colab tab. If your memory is running out. Okay.
What? I don't know. I'm getting my result.
Lucy,
Yes.
X is less than Y, so no output.
Yeah.
Oh,
X
X
is
is
less
less. Sorry,
Yeah.
thank you. Thank you for saying that. Okay, so
Lucy, you're fine. My teacher,
Thank
my Java
you.
people
Actually-
teacher is like that.
that is what I wanted to show. So thank you for that. I like that. So that is basically what I wanted to show. But when we are working with simple if, we will only get the result when the condition is true. So if X is greater than 10, then our result will come out. But the moment we have our X less than Y, we will not get the result. Basically, that is what I wanted to show. And thank you, whoever marked that. So that's why I was saying, but only when a certain condition is met or satisfied, a simple if only has one condition to check, and it will not do it if that is not right. So how do we solve this problem? How do we solve the problem of simple if? We use if else. So with if else, the syntax of Python goes, if condition full colon, then indent. Do this if the condition is true. Else, do this if the condition is false. So in our Colab, I will just improve on this so that we are able to do something if the condition is false. Remember, this is the syntax, and this is very important. If X is greater than Y, full colon, indent so that you show the block of code to be done if this condition is true. Then else, full colon. If and else are on the same line, this is indented, and then the next one is also indented. Print X is now less than Y. If I run this code now, it will tell me X is less than Y. If I change the value, it will go for X is greater than Y. What if I have this? X and Y are equal. Will this structure help me to solve the problem? If I run this code,
No.
it will not help me to solve the problem, because now I have not set a condition that will capture if X and Y contain the same value. So that is the reason now we go for a different structure called if, elif, else, a very important code that I must talk about. If, elif, else. For Python, it is elif. So those who have been using else if, it is elif. The syntax is if condition 1. So you give several conditions. Condition 1, full colon. Do this, condition 1 is true. Elif condition 2. So you are putting another condition. Elif condition 2. Do this if condition 1 is false, but condition 2 is true. Elif condition 3. Do this if condition 1 and 2 is false and condition 3 is true. Elif condition 4, elif condition 5, just go until you reach elif condition n. Do this if all the conditions from 1 to n minus 1 is false, but condition n is true. else. So else has no condition. It is the statement to be done when all the above conditions are false. An example would be if you're grading students maybe in class, you'd say those who get A must have maybe a grade from 80 and above, and then those who have B maybe are getting 70 to 79, those who have C. So you're saying the conditions as they go until now you reach a position where all the conditions have been checked. If none of them is true, then you do the else part of the program. And that is this is the structure that will help us to solve this problem. So when we are here, now we change this to be a leaf. So we say a leaf, and then we give the condition, a leaf, X is less than Y. So we have if X is greater than Y, print that a leaf X is less than Y, then print X is less, oh, we had that already. We have that already, so we don't have to do it again. We just have it there. And then now the else part. So else come here. So we have else, and then we say print X and Y are equal. So now when I run this program, it will say X and Y are equal. If I have my Y as 1, it will say X is greater than Y. If I have this as 110, it will tell me X is less than Y. So I'm able to now solve all that problem. The next if structure is the one that I called the nested if. The nested if. The syntax, so the nested if is that there are conditions that are several, but you must check all of them before you do something. They must be satisfied before you do something. If condition 1, if condition 2. So this if is indented within the other if. If condition 1, then you indent if condition 2. Do this if condition 1 and 2 are true. Else, do this if condition 2 is true, is false. Else, do this if condition 1 is false. So this else is on line with this. They are brothers, and then this is in line with this. Let me just show that without typing it because I already have one. And I want to give you a very practical example on where you would use that. There are some situations where people are given scholarships and you are told that for you to receive that scholarship, you must be a female, you must have scored an A grade at Form 4, and you must be coming from Africa as a continent. So we are saying the gender is F, continent is Africa, and grade is A. So if I run that, I've captured that. So I'm saying if grade equals A, if gender equals F, if continent equals Africa, print you got the scholarship. Else print, sorry, you are not from Africa. Else print, sorry, you are not a female. Else print, sorry, you didn't get the required grade. So if I run this with all these conditions satisfied, it tells me you got the scholarship because gender is F, continent is Africa, and grade is A. If I change the grade to B and I run it, it tells me, sorry, you didn't get the required grade. So that is the reason you did not qualify. If I change this to A, but the gender is male, it will tell me, sorry, you are not female. So that is the reason you did not qualify. You could be female, but you're coming from Asia. You're coming from Asia and not Africa. So I run that code and I run this code. It tells me, sorry, you are not from Africa. So basically, that is the selection, the four of them: simple, if else, if else, and nested if. The next control structure is repetition. And now I'm almost done. A repetition statement is used to repeat a group or block of programming instructions. In Python, we generally have two loops or repetitive statements. We have the for loop and we have the while loop. For loop is used to iterate. I want you to mark this very clearly. For loop is used to iterate over a sequence that is either a list, a tuple, a dictionary, or a set. Mostly, we will also use a for loop to iterate over a range of some values using the range function. We can execute a set of statements once for each item in a list, in a tuple, or in a dictionary. So what happens is that we have our list. I know George talked about that. We have our dictionary, or maybe we have our tuple. Inside the list, normally we have values. So we would separate them like that. They can even be similar, but they are inside there. So let me put an L up. Now, for loop will help us to go within this list and iterate. So it will be demarcated by the beginning of the list and the end of the list. So as you iterate, you are iterating knowing that the for loop demarcates, it knows where to begin and it knows where to end. So that one you must have in mind as we are working with the for loop. So let's think of an example where we want to print individual elements in a list. How do we do this? Our list is referred as A, so we have banana, apple, and Microsoft within it. For me to print this, I would say print A at index 0, print A at index 1, print A at index 2, and so it will print this for me. I'm thinking if this list has 1 million or 1,000 members of this list, then I will go from print A at index 0 up to even print A at index 1 million. My friend, that will be so long. So how would I do this in an easy way? I use the for loop to help me loop over banana, loop over apple, and loop over Microsoft. So using for loop to do the same, I would say this is my list. For element in A, print element. Okay, so this is where the problem begins. What is this? This is a variable. You can call it E, you can call it member, you can call it anything. But what it means is that this element variable will be the one to do the counting. It will act like a count variable to show that I have moved banana, apple, and Microsoft, and I am done with the elements in that list A. So we say for element in A, print element. And so it will be able to print for me banana, apple, and Microsoft in that order or in that manner. A range can also be used. So using the range method, I want to use the range to show, like, to display 1, 2, 3, 4. So I use for I in range 1 to 5. So every time you use a range, the CPU knows the range, because this is math. It knows that between 1 and 5, there is 1, 2, 3, 4. So the last one is not always considered in a range, the last one. So the range of 1 to 5 is 1, 2, 3, 4. If I say a range of 1 to 100, then I mean 1 up to 99. So the last one is not considered. And that is the way you would do it. And I'm giving you an activity maybe to try during your own time. Print the sum of numbers in the range of 1 to 20 if the number is a multiple of 3. So here, for you to be able to tackle this, you will have to ask yourself, how do I get only the multiples of 3? And then how do I now loop so that I'm able to get the sum of 3 plus 6 plus 9 plus 12 plus 15 plus 18 without touching the others. So you have to use selection to pick on the multiples of 3, and then you use the for loop in a range to help you with 1 to 20. So for 1 to 20, you know you will be doing 1, 21, so that your 20 is captured if you need it. The break statement to get out of loop, this is also used. So given list 2 containing these values, and these values are in a sorted manner, in descending order. So we have 5, 4, 4, 3, 1, and then -2, -3, -5. And we want to calculate the total. So we are saying for element in given list 2, if element is less or equal to 0, break. So this will help us only calculate the total of positive numbers, because anything that is 0 and below will not be captured. So once it starts working on this, it will add 5 to 4 plus 4 plus 3 plus 1, and then it will break because -2, -3, -5 is less than 0. So it will give us the total of the elements, but which are on positive side. So you would use this, like, for example, in Kenya taxpayers, you only pay tax if you earn a salary of like 10,000 and above. Sorry, somebody talking? Okay. So you only calculate salary for, you only calculate tax or take tax from people earning 10,000 and above. So you would say if salary is less or equal to 10,000, break, so that you don't tax those who are earning less than that. While loop. In Python, while loops are used to execute a block of statements repeatedly until a given condition is satisfied. So mark the difference between a for loop and a while loop. When we are using a for loop, we consider the data structures, the list, the dictionary, the range, and we also consider tuple, the set, those data structures, or we give a certain range. But when we are using while loop in Python, we loop over statements repeatedly until a condition is satisfied. So you give a condition and you tell when it is satisfied. And so those are things that you must do. So this is what I want to do in the column so that we get the comparison between the while loop and the for loop. So I want to show, that, and then I'll just be done. I want to write a program that will help me calculate the total of values in the range of 1 to 10. For me to do that, first I assign 0 to my total or to my sum. Why I assign 0 is because memory is not free. So if I just start, it will not know where to start. So I must put a value in that memory. So I'm putting a value 0 in total so that when I am calculating sum, it will only give me my sum. So I will say for elements, so let me use E so that you don't say it has to be that. For element in range of 1, and we were dealing with 1 to 10, then there must be that full colon, remember it. Then we are saying total is equal to the original total plus E. So you would say total plus equals E, or you would just say total equals to total, the original total, which was 0, plus now the elements, and then plus elements, and then you come back and you print your total. So if I run that,
The first total starts with a capital T, Lucy. So it's, yeah.
I've changed just the first one. It would have been faster. So that will give me 45. So how would I do this using while loop? It will be different because now with while loop, I will again set my total. So this is a different total from the other one, equals 0. And then I assign a value to a count variable. So I'll have a value that helps me to count. Let me call it count V to show that it is a count variable. So I assign it to begin at 1. Then I start, I say while my count V, my count variable is less or equal. No, it is less than 10 because I'm working with that range, so it can't be equal. It's less than 10. There must be a full colon here that you can't forget. Then I'm saying now total is equal, total plus equal, I had explained the meaning of that, total plus equal my count variable. And then, very important thing, I have to increment my count variable. So my count variable is equal to the original one plus 1. And then I get out of the loop and I print my total. When I run this, it gives me 45. So how does this work? You see the way it is done here? And now in this one here, the first thing I did was to assign my total 0, and then I show it where to begin. So this is very important. The first thing you do is initialize a count variable. Number 2, set your while condition. Number 3, indent the block. So within the block to be done is an increment or a decrement of the count variable. If you don't increment or decrement the count variable, then it means this count variable will remain at 1. And if it remains at 1, then this program here will loop forever. It will never stop. It will loop forever. If I just make a mistake of doing that and run this code, I want you to see this, what this green color is doing. It's coming here, going back, coming down, going back. And it will do that until Jesus comes to take the church, because it will not know this value remains at 1, and we are saying while count variable is less than 10. So for us to change that, we only need to do that, and then we do it, and then it works for us. So that is very important. Increment, once you initialize it, have a way to increment or decrement it. That's the same way when you're earning your money or you are withdrawing your money. Once you withdraw, the account has to reduce by the amount withdrawn. If the account does not reduce, then you can withdraw forever. For you to be able to stop withdrawing, then the account has to reduce by the withdrawal amount. If you deposit, the account has to increase by the deposited amount. So you increment or you decrement for you to be able to continue doing it repeatedly. The activity that I'm leaving us with is write a program that uses an input function to input 5 scores, calculate the total and average, then use the following grading system to grade the results. So you will be able to do this during your own time. Give to your Kamkunji mentor so that your Kamkunji mentor can mark it. Don't give this to Migot. Give it to your Kamkunji mentor who give it to me. Blessings, and that is the end of my presentation. Thank you. I'll push it back to Monica.
Hi, thank you so much, Lucy. Is everyone still awake? Maybe you stretch. We are getting into another session of discussing further into what Lucy has presented to us. And that is why we get into the object-oriented programming, which Python is part of, where we can use and reuse our code. So if you allow me, I'll go ahead and share my screen. And I'll show my face to, yeah. So I'll go ahead and share my screen. All right, 1 second. I'm gonna minimize all this stuff at the end and slideshow. All right, so I'm gonna be talking to you about functions, and you may wonder why we need functions. So Lucy, thank you so much for walking us through the algorithms, the pseudocode, and how we would code. But at some point, even in life, when somebody has already done something, you somehow want to clone or reuse it just to save on time. So I'll introduce you to a concept that helps us do that, and this is called functions. So what are functions? So functions provide a way to break problems or processes down into smaller and independent blocks of code. So from we can break down that definition by saying that a function is a block of organized reusable code that is used to perform some tasks. I want you to note the word reusable because that means it can be used over and over. And then it is usually called by its name when its task needs execution. And then you can also pass values to it and have it return results to you. Now, a good example of a function, like I know one of the assignments that we got was to convert, I believe it was Celsius to Fahrenheit. you can put that, if you work in a company where that is a frequent calculation that is done, you can just put that in a function so that once one person writes the code, anybody else who wants to reference that, they can just go and call that function, and then they won't have to write the 10 lines of code or however many lines of code that are involved in creating the conversion from Celsius to Fahrenheit or vice versa. So some important stuff. Whenever you're defining a function, you have to use the def keyword, meaning DEF, and it has to be all lowercase. So this is a keyword that comes before its name, and it is followed by parentheses, which come before a colon. So as we mentioned, functions are tasks that one wants to perform. So this is a good example of how we would define a function. So remember we said there is this, oops, never mind, sorry. There is the def, which is the keyword, and then put a function name. And we also can put what we call docstrings in a function. This is just a notation to give whoever will be reusing your function or whoever wants to go and call your function some direction as to what you're doing. So, and then I'll move over to the next slide. So I know in our discussion or in the notes that you got, the note or whatever the document is that is saved on your Google Classroom says functions and methods. So you may be wondering, what's the difference between functions and methods? So Python method is like a function, except that it's attached to an object. So we call a method on an object and it possibly makes changes to that object. So simply put, a method is just another function, only that it belongs to a class, okay? But Python functions is a sequence of statements that execute in a certain order, given a name, which is what we just mentioned. And then they let us implement code reusability. The example I gave, once one person writes the formula how to convert Celsius to Fahrenheit, we can all go to that function and call it instead of writing 10 lines of code. Now, over to the next slide. You may be wondering, how many do we have different types of functions? Yes, we do. So we have built-in functions, and then we have user-defined functions. Now, we'll talk about built-in functions, and I'm sure by now, when I go to the next slide, a lot of you will see that you've already used some knowingly or unknowingly. So some of those, I give a good example is like the format function, which it formats a specified value into a specified format. So this would be the syntax here. So you do the format and then the format. So like a good example, if you do an x equals to format and then 0.5 and you want to format that into percentage, we know that is 50%. That is why you would get this output down here. And then we have the length function. So this will help to find the number of items in either your string, your list, your tuple, or whatever data structure that you're dealing with. Now, so this is just the syntax. It shows the length and the object. So in this case, where we wanted to find the length of my list, which is string hello, it gives us an output of 5 because hello is HELLO, which is 5 letters, right? So over to the next one. Oh, this one we have used it every day in all the assignments that we have been given. So if you didn't know, it's a built-in function and it prints the specified message to the screen or other standard output device. So the syntax, as you can see, it's you print your object. If it's a string, you have to double quote it. If it's a total, like what Lucy just did, then you just write the total. And then there's all these other parameters that you can set in there. Like if you want to separate with, you can specify your separator or you do an AND, which kind of will print your output either in a row or vertically. And you can look more into that. So a good example here, which we have done, probably all of us have done this. So the output gives you hello world. Now, before I talk about the other set of functions, which is a user defined, I want to outline some of the components that make a function complete. So number one, it's a function name. Just like all of us have names, functions also need names because if you're going to call it, you have to call it by a name, right? That is, if somebody calls nobody would know who is being called if we didn't have names. So what do the names do? They uniquely identify the function, and the function naming follows the same rules as those that we defined last class for defining variables. So like it can start with an underscore, but it can start with a number. So just read your notes on that. And then the other component of a function is that it has to have a colon, right? And this marks the end of the function header. And then there is the optional docstring that we mentioned to describe what the function does. And then there is also, the reason we have this is because there is also a parentheses around it. And then there are parameters which are interchangeably used. So you'll hear these words interchangeably, parameters and arguments. So what are these? These are through which we pass values to a function, and they are optional. So, and again, one or more valid Python statements make up the function body. So statements must have the same indentation level, usually 4 spaces, but usually this is something that you don't have to sweat about because most of the IDEs will automatically do it for you. But you have to make sure that your function has a colon. As you saw when Lucy was writing her if statements, if she didn't put the colon, the full colon, then it was jumping over and wasn't indenting. So if you want your IDE to help you along, then you have to follow the best practice. And then in a function, you'll also find an optional return statement to return a value from the function. Now, I just wanted to give us a definition of the parameters or arguments. So a parameter is the variable listed inside the parentheses in the function definition. So if I was to go in and define a function, right, and say something like define and then call my function name like my underscore name, right? I'll put the parentheses and do this. Anything that I put here is called the parameter. So as you say here, the parameter is a variable listed inside the parentheses in the function definition, right here in the definition. Now, what is an argument? It is the value that is sent to the function when it is called. So it comes to a point where you define, and then when you want to reuse it, you call the function. So what you put in the function when you're calling is known as the argument. Now, having said that, we're gonna look at user-defined functions, okay? So we said whenever you're creating a function, it has to have the keyword defined, and then you give it your name, the parentheses, and then the colon, and then you give it the output. What do you want it to output? Is it print hello from a function? If that's the case, then when you go in and call your function, so calling the function, you would just say my function and then make sure you put the parentheses, otherwise it will not really return anything. So defining and then calling. Calling, you just call the function and make sure the parentheses are always called. And I'll show you this in the IDE, so it makes more, it at least cements the concept. Now, we also talked about another component of functions, right? So this is the name that we talked about. Now, the other function is the docstring, which tells us, it's just a way to give a short documentation on what exactly is your function doing. If we are converting Celsius into Fahrenheit, that is what you would exactly write there, or converting minutes to hours to minutes. So how do you call your documentation? So you go in, define your function. If you want to see the documentation, then you would print your function name dot underscore underscore doc underscore underscore. And we are going to see these two in the IDE. Now, over to the next component, we also talked about the parameters. So remember, we talked about the function name, we talked about the colon, we've seen that. We talked about the parameters. So there are, so whenever you're defining a function, depending on what you want it to do, we say that parameters are optional. But in the case of this one, I want to show you where we put a function. So like here, you're defining a function, right? And then you're giving it a parameter called fname. And then what you're telling it to return is fname plus this string, ref, s, and s, ref, snesses, okay? So when you call your function, you have to give it something because you already said that it needs a parameter, right? So when you're calling your function, then you put an argument. Now, the difference between a parameter and an argument, we already mentioned that the parameter is exactly what you would put up here when you're defining your, right here, when you're defining your function. And then these are the arguments. Now you know the actual value that you wanted to call the function for. So like here, you want to return a name and have this as a last name. I would imagine these are family members. So if you have 3 kids like me, then it will be Emil, Tobias, and Linus. And then this would be the output right here. All right. So we are talking about parameters you can give, and then you specify them as arguments. Now, which other way can we provide parameters? So you can also give parameters default values. This is a good example here. So as you can see, in the previous, if we had written it the way I just showed in this previous slide, I would just specify country. But here, what I have done, I've said country equals to Norway, right? And you're asking it to print back, I am from the country. Now, I want you to watch what it's doing. When we call the function, so we are calling it 4 times, right? So in the first 2, we are giving it an argument, which is Sweden, India, you can even put Kenya, Uganda, whatever. But if you leave it blank, it knows to go for this default value that you put here, Norway, right? So that's why the output to your right shows I am from Sweden, I am from India. And of course, the third one, you didn't give a value. It goes in and checks was there and it defaults. And then that's why it gives you Norway and then Brazil, which has been defined. All right, now we've talked about parameters. Now, the other component that we talked about is the return value. We said it's optional, so you can either do a print or do a return. So in cases where we do like arithmetic calculations, a return is the most ideal approach to use. So this is an example here where you do my function and then you give your parameter x. And what do you want it to do? You want to return 5 times the value of that x. So what you do when you call your function, you would print my function 3, my function 5, my function 9. And so in this case, what it's going to do, it's going to go in here and look what exactly you wanted it to do. So it's going to take 5 and then multiply with 3. And that's why you have 15 here. It will take 5, multiply with this 5 here, multiply with this 5 that you sent as an argument, and then it'll give you the output. All right, so with that, I would want to move to the next slide and introduce you to this other concept that was in the notes about the arbitrary arguments. And these are denoted by a single asterisk. And where do you use the arbitrary arguments? So if you're not sure how many arguments will be passed into your function declaration, simply add an asterisk before the parameter name in the function definition. Okay, you don't know how many arguments, like when you're calling your function, these are the arguments, like in this case, so like in this case, whenever you're defining, you don't know how many of these will be put in here, right? So what you do, you just put the asterisk before the president, and then when you're calling or when you tell it what to output, you want to say the name of the first president of Ghana is presidents, right? Which is the parameter that you put here. And then you want to take the second index. I'm sure I don't know if we talked about index, but in Python programming, this Kenneth Kaunda would be index 0, Mwalimu Julius Nyalele would be 1, and then Kwame Nkrumah would be 2. So that is why when you try this, it would print out that the first president of Ghana was Kwame Nkrumah. All right. Now, alternatively, you can also pass like a key value syntax. And I know we are now familiar with key value because we have done what we call dictionaries. So this case, you would define your function and then you put your parameters, engineer 3, engineer 2, and 1, right? Or A and G. And this can be anything. So then you would want it to output the youngest scientist was, you concatenate it with ENG3. But now when you're defining your argument, you already have defined the value of the engineer 3, who is Einstein. I want to say scientist, right? So in this case, what you would get back would be, since you're calling the engine in scientist number 3, it would be Einstein. So that's it about the arbitrary arguments, which come with a single asterisk. And again, if you don't know how many arguments will be passed in your function, this is when you use that. So over to the next slide, we'll be talking about the quags, or that's what I call them. And these are used when you don't know how many keyword arguments will be passed into your function. So you add 2 asterisks before the parameters in the function definition. So in the function definition, this is where you would put your 2 asterisks, okay? And then the return statement would be his last name was activist, and then you do your L name. So in this case, what you would get here is that his last name was X, and I would imagine they are referring to Malcolm X. Now, we have another set of functions called lambdas, and I'll fly through these ones. What are lambda? What is a lambda function? It is a small anonymous function, and I want you to note this, that it can take any number of arguments, okay, but can only take one expression. What do I mean by arguments? What do I mean by expressions? So this is the syntax here. Now, as you see, there's a lambda arguments, and then there's a full colon and then expression. Anything to the left of the colon, you can put as much as you want, but to the right, you can only have one expression. So a good example here is the, we're defining X equals to, and you have to use the keyword lambda. You're just defining A as the argument, even though you have the flexibility of defining A, B, C, D up to Z, right? And then the expression that you're giving it is that you want it to add a 10 to the A value that you're going to give. So in this case, when you're trying to get your output, you would do print X, and then you put 5. And what it does, it comes here, replaces this A with this 5, and then it adds 10, and that's why your output on this side is 15. All right, so that's a little about lambdas. And in my next slide, I'll be showing you how you can use lambda functions with multiple arguments. We said you can have as many arguments, everything to the left of the colon, but to the right, you can only have one expression. So a good example is this one. So you have lambda AB, and then the expression is A times B, okay? So AB, that's multiple, and you can even do 3 of them. Like here we are doing ABC, we are adding the AB, C, A, B, and C. So like here it would do 5 plus 6 plus 2, which is why it outputs 13. And here it would do 5 times 6, and that's why it's outputting 30. Now, why do we use lambda functions? So the power of lambda is better shown when you use them as anonymous functions inside another function. So this is just an example, and you can do more practice on your own just to get familiar with the lambdas. And before I move on to the next topic, I just want us to go into my Colab here, my Jupyter notebook, and I'll just show a few of those concepts that we talked about. Or one more thing, if you don't know exactly what you want to put in your function, right? You don't have all the specifications or the use case, you can just define your function and then use this pass. It's a keyword. And what it does, you can run this and then you won't get an error. But if we just left this hanging, so like if I was to comment that out, sorry. Oh, it would still run, but it's a good practice to just leave it here because you don't have any functions, you don't have any arguments that you're passing. Now, we also said that you define a keyword, you define a function, you give it a name, and then you give it a parameter. So in this case, and this is the example that Migot had in the notes. So there is the function called greetings, and then we are passing a parameter called name. And if you remember, we also talked about the docstring. Remember, to specify a docstring, you have to put the 3 quotes. And whenever you type the 3 quotes in Python, like I'll do 1, 2, 3, right? It does the opening side and the closing side. So you don't really have to go and type them again. All you need to do is to go in there and put in your code. So like this function, greetings to the person passed into the parameter. So, and then you would need a print statement or a return so that at least when you call your function, it knows what to do. So like in this example, I have said, when this is executed or when this function is called, I want you to go and print habari, which is greetings in Swahili, plus the name that you specified as a parameter or the name that you will specify in your arguments, and then siku ya leo, which is today. So if I was to run this, guess what? It's habari mwanafunzi, which is student, siku ya leo. And I had to call this, okay? I had to go in to do this greetings. Remember when we said about calling a function. Now, assuming I just called my function and totally ignored that I had a parameter on here, what would happen? So if I do this, okay, I'm calling a function, it's expecting something, right? Like a name, but I'm not sending anything. So it says the type error is greetings, missing one requirement, positional argument name. So yeah, it will be mad at you. So you better go in back there and just say Monique. And so now I have an output. So about printing out the docstring, you just do print and then the function name dot doc. So when you run this, what you get is nothing but what I have in these 3 lines, from line 3 way up to 6. Now we also talked about the quags and the args. So I'll show the double asterisks, which is the quags. And then if I run this, remember we said that it's gonna print out his last name was X. And that is because we have specified the activist, who is the parameter we called here, and then last name from the argument that we are given. Now, you can use functions, as I mentioned, like you wanna, like when you get a task like converting Celsius to Fahrenheit or hours to minutes. And as Lucy mentioned, before you execute your task, think about the use case. Write down some pseudocode, which is English code anyway, to just give you an idea of what you're supposed to do. So like in this example, this is a question that was given. Define a function called calculate_minutes so that given an amount of time specified in hours and minutes, the function returns the total number of minutes. So for example, given 3 hours, 15 minutes, it should return 195. And where does it get 195? So we know there are 60 minutes in an hour. So this is from way back. And then to get the minutes, total minutes in an hour, you would take the number of hours times the minutes. And remember, parentheses define the order of precedence. We talked about that. So when you define the function, this is how I did it. So calculate minutes, and then I gave it its 2 parameters, okay? And parameters can be anything, because at this point you really, at least this time we know what it is, but you can call it anything. And how are we gonna get our total minutes? We are gonna take the X, which is the hours, and then times 60 plus Y, which will be our minutes. And then we give it a return statement. What do we wanna see? We wanna see there are, however, total minutes in 3 hours, 45 minutes, let's say, okay? Now, if I was to run this, I wouldn't expect anything in return because I haven't really called my function. So the other thing is, whenever you're calling your function or whenever you're putting in your arguments, you can call them anything. So in this case, like I'm calling Masa, which is Swahili for hours, and then dakika, which is Swahili for minutes. So if I was to run this, and again, I'm using an input statement, just trying to cement on some of these concepts. So it tells me, because enter the number of hours. So let's say 3 hours, and I'm just gonna go by the example here, okay? And then dakika equals to enter the number of minutes, which was 15, right? So when I enter, I call my function, okay? And I tell it, input the masa, the 3 hours, and then 6. And because I told it, take the 3 hours times 60 plus the 15, that's why it's telling me there are 195 minutes in 3 hours and 15 minutes. So I will land this plane called functions, and I will move over to the next slide and cover our next topic for the day, which is classes and objects. All right, I'm pausing here to let everybody breathe, but I'll breeze past, and then we will leave the questions for later. So what are classes? What are objects? So I have a definition here. Not I have, but got it from, programming sources. So what is a class? A class is a blueprint for how something should be defined with its attributes. Classes do not contain any data. So to digest that a little, many years ago, when the Wright brothers created the plane, they had an idea and they just put the bare basics. So I would imagine that plane had wings and they had the tires, I think they call them tires in the plane, and then the tail, the cockpit, and some whatever, okay? That makes just the blueprint of a plane. Then later, came Boeing, and now they have all these versions of Boeing, however Boeings, So, but the blueprint is what contains the bare basic of a plane, or I guess all of us have seen a plane and a car. So a car, we know it has to come standard with windows, it has to have tires, and then it has to have doors, right? Because people have to get in and out of the car. So if you are to create a class car, you will just define the bare basics. But then the next sentence says, while the class is the blueprint, an instance is an object that is built from that class and contains real data. So in the example of a car, if we were to create an instance, all right, or an object, we would do something like, let's say a car, I would do Toyota, well, let me do a BMW, maybe C-Class Mercedes, right? Now that is the object because we are taking out of the car, and then now we are going to define that it has 5 doors. It has, I think it has 5 doors, and then 4 windows and however many seats. Now, this object, an object is a collection of data variables and methods, functions, which act on the data itself. So when you define the object, Mercedes-Benz, whatever class, then you give it all these things that make the Mercedes, right? Because it's just not a car, it has all these additional features, which would differentiate it from the Pro Box. Now, an object is also an instance of a class, okay? And the process of creating this object is called instantiation. So when you go and give your Mercedes or your Pro Box the 5 doors and the number of passengers it can take, then now you are instantiating the object of that car, okay? Now, an object contains data like the raw or pre-processed materials at each step in an assembly line, and behavior like action each assembly line component performs. So I'll give you an example, like a person like me and you, we have properties like name, age, and because we're in the advanced age, we have, or in the advanced technology age, we have email addresses, and of course we all live somewhere, so we have an address. And then we have behaviors like talking, walking, breathing, and running, okay? So all these compose a class. And as we move on to the next slides, I will also be demoing like real life examples so you can see what exactly I mean. So with that in mind, we'll also go over some classes must-haves, like whenever you define a class, what should it compose? So it has to have the class keyword. So we saw in functions, you define, whenever you're defining a function, you would say def, D-E-F, whatever the function name. In a class, you would say class, assuming it's called car, then you would say class, C-A-R. Then there is also what we call init. And for the sake of this underlining, there's 2 underscores before the I and then 2 underscores after the T. And what is init? It's a method or a constructor in Python. So the init function is called automatically, okay? And we want to underline this. It's called automatically every time the class is being used to create a new object. So like if we were to go and create Mercedes C whatever class, it would call this function init, okay? So all classes have the init method, and we usually use it to initialize all the variables. So if you think about init, it's actually the first function or method that you create in a class. So the first string inside the class is called docstring and has a brief description about the class. Although not mandatory, it is highly recommended. We talked about docstrings when we were talking about the function. So similarly, we have them here in classes. And then there is what we call self. Now, this can be replaced with anything. I can even call it Monique, but best practice requires that we call it self. So what is self? It is an instance of an object. It's an instance or an object of a class. In Python, this is explicitly included as the first parameter. It's explicitly included as the first parameter. And it helps differentiate between methods and attributes of a class with local variables, all right? Now, I will be showing you this so it can sink in more. And then the other thing, I don't know if you can see because I have something hovering around here. Python class names are written in capitalized words, notation by convention. What that means is, so if I'm creating a class, I would write something like class, and then it would be car, okay? And then I will put a full colon, or I would say class, something like a house, okay? So this has to be capital, the C and the H. Now, moving along, now that we know the must-haves in a class, what exactly is this that we were talking about in all that theory? So classes and objects, right? We have seen those words come up and again. So assume you're creating a class called employee, right? You would call it class employee, and then it would have all these characteristics or properties. Employees have names, they have age, and of course they are defined by some salary. They don't work for free, right? Now, when you have a class, we say that you create an object and instantiate the objects, right? So if you are to create object one or employee one, then you would say object one or employee one equals to, you call the class, which is an employee, and then you instantiate by putting the name Sarah, then the age is 37, and then their salary is this much, and on, depending on however many objects you have, all right? So with that, I want to move over to the next slide. And what are the compositions of a class? We talked about variables, instance, and all that, but just to show them in a more pictorial way, pictures speak more than 1,000 words. So, and just to go over what we said the class is a blueprint from which specified objects are created. So this is a class. In a class, we have class variables, okay? Now, a class variable is shared by all the instances of a class. Like it's all the way up there. If you think about the hierarchy, it would be the class at the very top, and right below the class name, you would have a class variable, which works on everything that would be called thereafter. And then we have the instance variable, which is unique to each instance. A good example is age, weight, or salary, right? And then we have the method, which is the functions that we define inside a class. And as we said, our definition init is the first function. Now, with this in mind, I will also be showing this in the IDE, so at least we can comment on this. You may be wondering, why do we even have all these classes and then there's all that? I'll just touch very briefly on this, and I know Migot will be covering it in the other session, but you may be wondering, why do we even create classes? I mentioned about object-oriented programming, which has 4 components. Inheritance is one of them. So a class can inherit attributes and behavior methods from another class called the superclass. So like in this case, the vehicle would be the superclass, meaning everything that we create here can inherit anything that we put in here, all right? So like in a case of a car, if it's a Pro Box, it has doors, right? Only that it has more doors than, or to specify something more specific about. And then another thing is a class which inherits from a superclass is called a subclass, also called their air class or child class. So this is the superclass, and these are the base class, and then we also have the derived classes. I'll save that for a later lecture, but I wanted you to at least have an idea of why do we even do classes. So now with that, let me go over to my IDE and I will show you some of the things that we talked about of the classes, right? So assuming we wanted to define a class called students, right? Remember we also mentioned about this pass in the, when we're talking about functions. So when you don't really have all the information you need, you can just create your class and then write pass. So when you run it, it doesn't return an error. Now, assuming you created a student class and then you wanted to at least specify your students. And this here is what we call creating of the objects, okay? And then when we give the objects their values, this is what we call instantiation. Now, if you walk with me here, so we are creating an object called student1 and student2, and we have to call the student class because without the relationship, you can't really inherit what you had dictated in your class. And you will see this as we go by. So if you wanted to make a student's first name and last name, ignore the typo and the email and the score, right? The old method without a well-defined class would be, so you would come here and say, okay, now student1.first name, you give the first name, and then their last name, their email, their score, on and on. And then if you want to print this, all you would do is run. But now, why do you want to do this tedious process? Imagine if you had like, what, 100 students in a class, like George has, I don't know how many in the blog so far, but if he was to do that, maybe he would have to hire an intern to do that for him. So came the savior called the init function, and I'll just read here. So the properties that all students objects must have are defined in a method called init, okay? And every time a new student object is created, this init function sets the initial state of the object by assigning the values of the object's properties. So that is, init initializes each instance of the class. What does all that mean? So now, and I had pre-typed this just for the sake of time. So this is to answer the question, what if you don't want McGott to go and type in all those 200 students, right? What you would do, now you would create a well-defined class. So you would say class student, please note, there is the class keyword, and then I'm starting with a capital letter, S, and then I'm putting my full colon, and then I would define with the init. Remember we said the init is the very first method that you create in a class, and then this is the self that we talked about. So you put the self as the first parameter, and then you do your first, because we want their first name, your last name, and their score, right? Now, anything that we define here, remember in my picture here, we said there are class variables and instant variables and then methods. We've already seen a method. We haven't seen a class variable yet. Now we're about to see the instant variables. So these are the instant variables. And whenever you are creating your instant variables, you have to have them in this format. Self.first equals to first, okay? It is preferred that you keep the same names. So you would do self.last equals to that, self.score equals to that, and then you can even create some on the fly. Like the email, we all know mostly it will be the first plus a dot or a full stop last, and then you can put whatever your email is at Gmail, at Yahoo. So now when we come to the object creation, so we are creating the object called student1, and then now we'll be instantiating it. Instantiating meaning putting all the values that concern that student1. So in this case, we have Linda, her last name is Doe, and then She's very good. She scored 85. And then we have a student 2 called Lisa. Last name is Kick, and then they scored 90. Guess Lisa is smarter than Linda. Now, if you want to print the student's first and last name, all you would do is to print that. And what if you wanted to see their full name, right? You can do this print function here, and then you call the format. Remember, we talked about format when we were doing our functions. So you would say student1.first, student1.last. Now, this is redundant, and I will show you how we can get away with that. So we got our output here. So guess what? We are getting Linda. So once you instantiate, you can call that student, and then you say the first, and it automatically knows that it's Linda. If you call the last, then, like in this case, it knows it's Cake. Now, when you say full name, you've already told it what to do. Go get the first name and the last name. So that's why it had the Linda Doe. So if you want to omit the whole step of now going in and printing and telling it how to return the full name, this is when you can go in and create a method. Remember, we said methods are functions in a class. So instead of running line 23, actually it's line 24 above. I'll be sharing this, so don't worry about if I'm flying too fast. You can create a method that allows you to put the full name into one place. So in this case, you would do, this is exactly the same you had, but then you would go and define what you call full name. Now, whenever you define a method inside the class, this is the parameter that you put in here, because remember, self is your very first variable in your class. So now what you would do is, and this follows the same convention that we did for functions, you would tell it what to return or what to print. And what I did, I just put in this function or whatever I had in here. But now what I did, I didn't put student1, because the purpose of putting a function within or a method within a class is so that you can use it in the whole class. So initially we had student1.first, student2.last, but now we're going to go into first, self.last. All right. So if I was to run this, see, I would just need to go in and say student1 and call my function that is tied to that student1, and that student1 is Lisa Doe. All right. Now, we talked about the class. We have talked about method within a class. And now we also talked about the variables, the instance variables. We're going to talk about the class variable. And we said in the order of hierarchy, it's the class and then the class variable, which is defined all the way up here. So like if there was anything like a student getting like 5% increase in their marks, right? This is where we would come in and call this score_raise. So this, but also once we do that, we also have to define or create a method as we call. So for example, we'll come in here and call or define another function which says apply raise. And remember, we said anytime you create a function or a method in a class, this self has to be your parameter. Okay. Then we would say self.score equals to self.score equals to, remember, you have to convert, you're multiplying numbers here, right? Scores is in integers, and then you multiply with that 1.5 that we specified here. So if we were to raise the student number 2 score of 85 with the class variable of 1.05, right? What we would get, where is it? All right, let me restart my kernel because it gets tired too. All right, what was this? Sorry. Oh, yeah, here. Actually, it did print. I just had some other stuff here. So here it is. So they scored 90, student 2. And again, whenever you're calling your function, you have to call it. So you call the score so that we can see what it was. You apply the function, which doesn't return anything, and then you call the student 2 with the applied raise. That's why you have a 94. So we've talked about the parameters, we've talked about arguments, we've talked about functions, we've talked about classes, the instance variables and class variables. And I would love to land this ship right here on the plane.
I have a question.
Yes.
It's rounding off the answer. Do you think maybe you should have said float?
Rounding off the answer?
In both cases. Is it
Which one?
like if you multiply the average the results by 1.5?
You can, depending on what it is, but in like we are talking about scores here. So it's better, you know, you have 100 or 95, not 95.2, right?
Oh, okay.
Yeah. But good observation, Sophie. I know that voice now, right? But good question. Yeah, so that's about it. And I'll be sharing this for anybody who wants to go in and practice this. Practice makes perfect. So I'll hand it over to Migot and I'll stop sharing my screen. Or do we have any questions?
Thank you very much, Monica. That was fantastic. Of course, Lucy, thank you very much for that splendid display of expertise. Now, having said that, is there any other question, like from anybody, any particular area you're not clear on?
Yeah, I see a question here from, please tell me, is it Idris?
That's Idris.
Idris. So is it possible to share an instant variable to other classes? So the answer to that is, it is possible through inheritance, which is one of the components of object-oriented programming. And yeah, we will handle this, or I can connect with you and show you, because it's a little high level for this. For at least I'll be going out of topic for this, unless George wants to do it.
That's in order, Monica.
Okay.
The good thing with classes, you can reuse the code, and by saying reusing the code, you can share. That means you can do the inheritance. So if you declare a class, the first class will be parent class, like Monica said, and then if the parent class name is let's say Adam, and then another class, parent class is say Eve. So we have Adam and Eve. I mean, if you believe in that, then the human class will be inheriting what Adam and Eve initially had as their attributes. Now, the attribute here is a property or the value or the characteristics of what Adam and Eve. Of course, we know human class, you'll definitely have to have 2 legs. You definitely have to have 2 eyes, 2 ears, hands. You'll be able to probably talk, see. Those are the attributes. So we inherit from that. Now to answer Idris' question, Monica, you're right. It's possible to do that through inheritance. We can do that through inheritance by basically inheriting from the superclass. Okay. Any other question? Any question for Lucy or Monica? Another thing you also want to make sure, whenever you're doing an input statement, if you know it's going to be something to do with a float, it will involve like a decimal point, you always want to do the float, don't do the integer, because otherwise it will create some kind of issues down the road. It will bring your program not to be accurate. Say you know it's going to be in terms of let's say 90.5, or it could be, let's say, 99.1. That has to be going through a float. So things to do with money matters, or things to do with some kind of conversion in metric, like in units, you probably want to go the direction of using floats. But unless it's very specific, like we cannot have fraction in terms of, let's say, how many people in that room. We cannot say there are 2.5 people. We have to say there are 2 people there. Then at that point, we'll use the integer. Okay. I know when it comes to functions and classes, it's a little bit complicated. So I would really encourage you all to find time, read again, and go back and read, and also practice. Come up with some examples, see if they can work for you. If you have any difficulty, please share in your Kamkunji, or you can also share with me, and then we can do it together. This part of Python, which starting with the condition statements, going to the loop, then going into functions. Of course, we have 3 types of functions. We have the inbuilt, we have the user-defined, and then we have the anonymous function, which we also call the lambda functions. If you get those down real good, then you should not have any difficulty when it comes to classes and objects. Now, if you get all this down, then anything in Python will be a free fall for you. But again, reading is not enough. You have to be able to practice. If you practice, you probably don't want to copy and paste. Type it. When you type it, they say some of your neurons will be building up to be able to help you remember than if you copy and paste. You type, make mistakes. Don't be afraid to not make mistakes. When you make mistakes, you correct them. When you correct them, you kind of like really remember. It comes back to you. When you get the same error again, next time, you definitely know that, oh, this is how I resolve the problem. Now I know. Okay. Practicing in groups is a huge plus. It helps. It might not work for everybody, but I've seen it work for most of the people. You probably want to practice more in groups. Yeah. Now, having reached that point, I'm going to go ahead and assume if there's no questions, then we should be good to go, unless somebody has a question if they want to ask. Okay. So today we covered from exception, handling exception, which I'd already sent notes out there. You should be able to get them in your Google. We also shared notes on pseudocode, algorithms, and examples, which Lucy covered today. You also have those in your Google Notes. We also shared sequence selection and iteration. Lucy covered that one today, and you should also have those in your notes. Now, the notes you see, those are summary. If you want to go an extra mile, there's so many books on Python out there. If you want me to recommend a book, I'll recommend one for you. And this is by no means insulting, but the name of the book is Python for Dummies. I still use it, and it elaborates a lot of stuff. So what I'll probably do, I'll share with you guys on Google. So you just click and then you should be able to read it there, or you can even download it. It's a PDF. Okay, and also, of course, Monica talked about Python functions. Functions, like I say, it's very important. Try to master those. Classes and objects. We also have all those notes available for you. So that means this is second Zoom session. Our third Zoom session will be covering section 3. And that will be a little bit more detailed, but I've already shared all the notes. So look in and see if you can get one point I would like to emphasize. Is regular expressions. It might not be very easy to understand, but you probably you need to read it. I shared quite a lot of resources. Please go and read and also practice. There will be something which I will be able to probably have a look at on what assignment 7 is covering. That's going to be on file processing, which we are going to be handling here pretty soon. Is file processing with dictionaries. So you probably want to check on that and make sure that your program is running. Don't submit if it's not running. You'll not be doing yourself any justice. Make sure it's running. You'd rather be late, but it's running. Don't just send it. Make sure it's running. It's important. If it runs, then you know exactly how to run it. If you're stuck, there's help out there. I'm available. Your team Kamkunji members are also available, and your mentors are also available. One thing you have to understand, nobody knows everything. Even me, I still good. So sometimes you ask me a question, I might not even know it off head, but I have to look it up. But when we look at it, when we look at such stuff together, it really cements the knowledge. It really reinforces it for you, and you will not have a lot of hard time thinking. Okay, somebody's asking about how about iPad users. What is a question for? I'm not really understanding that. What's the question about iPad? Okay, I'm gonna assume that's not necessary or relevant. So don't. If you want, you can ask it on the WhatsApp forum, but I'll be able to answer. Okay, Python. Okay, if you want to do Python, you probably want to do it on a Mac, on a laptop. Okay, and if you have Ubuntu, I mean, if you have Linux, that's also. But on iPad, you probably you'll be on your own on that one, because Python download isn't. Okay, you can do that, but you probably want to use Colab. Colab, you don't have to download Python. You just, if you have a Google account, you just type Colab on your browser. It will take you there, and then you can run your programs. Yeah, you'll get the you get the recordings. Like I said, Sophie, all these recordings are for you. They'll be available on YouTube. Don't worry. And Monica, I see she's already sent her notes, of course, after marking them. Okay. So you'll be getting also, Lucy had already shared. So you probably want to download those ones and then at your own time refer to them. Okay. I hope I answered all the questions. So for iPad, I have an iPad, but I've never tried to download Python on it. If you download and you're successful, good luck with that. But your best bet is to go to Colab and use it there. Okay, I'm not seeing any other question. Okay. All right, so that's good. So Python is powerful. Just learn it. Make it part of your daily routine. If you wake up, you pray, and then you go do your Python. You can do it in your head. But for those people who are planning to proceed to advanced Python, like I said, this is a good time to make sure, utilize the time, make sure you read the notes, because the advanced one will be 10 times harder. Not necessarily harder, but more intense. Okay. Having said that, I think we are good, and I'm going to go ahead and thank everybody for their time and for coming to the meeting. Okay. And I'm not really sure about the last question though. Python allows, but versions not. I'm not really sure about that. You probably want to type it clearly. Don't rush. Take your time. Type it so somebody can read it. Okay. If you need more assistance with the question on that iPad, let me know. But I would recommend Colab. Some maybe your iPad might be able to allow you to do that, but you will not do very much with that. With things like doing your Python on your phone or on your tablet. There's certain things on your keyboard which might not be available for you to work with. But if you are able to work with that, then that will be something we would like to hear from you. And then we learn as we go. But I like, personally, I like Colab. When you use Colab, you can type and then you just click, like the way Monica showed you, click and then you just go straight to check it out to GitHub. Okay, so Colab will always be good. I mean, it's helpful if you are like maybe borrowing a computer which you don't want to install anything, or you're in a lab environment. I mean, a lab or a library environment. You don't have to install anything. You can use Colab. Okay. Those are some of my tips, but again, we have WhatsApp. Make use of WhatsApp. Feel free to ask questions related to Python, and we will be able to answer. Okay. All right. Thank you very much, and I hope everybody have a good day until next time.
You too. Thank you.
Bye. Okay.
Bye.